Hi there. In the video, I'm going to be telling us about amount of substance, mole ratios, and naming of chemical compounds. To begin with, amount of substance. Amount of substance is measured in moles. It is defined as the amount of substance that contains this number of atoms or elementary entities that is found exactly in 12 grams of carbon-12. What this means is that according to Avogadro, 12 grams of carbon-12 contains 6.02 times 10 raised to the power 23 atoms. Hence, 1 mole of a substance is said to contain exactly the same amount of atoms as found in Avogadro's number, or stipulated by Avogadro's number, being 6.02 times 10 raised to the power 23. In calculations, we simply say number of moles is given as reactive mass divided by molar mass. Hence, 1 mole of oxygen will contain 16 grams of oxygen, and each mole will contain, according to Avogadro's number, 6.02 times 10 raised to the power 23 atoms. Mole ratio. Mole ratio is simply the ratio in moles of the amount of 2 compounds involved in a chemical reaction. Mole ratio is what gives us the stoichiometric relationship in chemical reactions. Take for example, the combustion of carbon in oxygen to give carbon dioxide, as given by the equation C plus O2 to give us CO2. From this equation, the mole ratio, after balancing, the mole ratio in this equation is 1:1:1. That is, the ratio of carbon to oxygen to carbon dioxide is in 1:1:1. Take a look at another example. H2SO4 plus zinc to give us zinc tetrasulfate 6 plus H2O. On balancing, we'll find out that the ratio of tetrasulfate 6 acid H2SO4 and zinc to zinc sulfate and water are in the ratio of 1:1:1:1. Another example is given when calcium triisocarbonate 4 reacts with hydrochloric acid to give calcium chloride, carbon dioxide, and water. On balancing, the equation becomes CO3 plus 2HCl to give us calcium chloride plus carbon dioxide and water. I will find out that the ratio between calcium triisocarbonate 4 and hydrochloric acid in the latter equation is 1:2. Hence, mole ratio tells us the ratio, the amount between two compounds in reaction in a simple ratio. Now, let's talk about naming of compounds. The naming of compounds today is done using the IUPAC standard, and the IUPAC standard involves the use of oxidation numbers in naming compounds. Take for example the compound H2SO4. This is called tetraoxosulfate 6 acid. Tetra also because there are 4 atoms of oxygen, sulfate 6 because the sulfur there is having an oxidation number of +6, and since this is an acid, we call it tetraoxosulfate 6 acid. Another example is NaNO3, sodium trioxynitrate 5. This is so because the non-metallic part, or the electropositive part, sodium, followed by trioxo, having 3 oxygen, nitrate 5. Nitrogen in this molecule is having an oxidation number of 5. So the naming of our compounds in chemistry is done using their oxidation numbers. In the next video, I'm going to be telling you about the laws of chemical combination